I am Dr. Manu Gupta. This is my first lecture on Ansys series. Here we are going to perform analysis of very simple cantilever beam. It is a tube of 500 mm length and outside diameter is 25 mm, inside diameter is 21 mm. Here I have solved this problem analytically and find that result of maximum deflection is 6.18 mm and maximum stress is 64 megapascal. Now we will perform analysis by Ansys and check that these results are same, or what is the difference between these two results. Now I have opened Ansys workbench. We are going to perform structural analysis of static structure. Drag and drop here. A small window here is showing our progress. Now I will apply material to our model. I will double click engineering data. Here I can apply the material or remove the material as per my requirement, like I have deleted air. Or if I want to add another material, right click engineering data source, general material, I can select any material, right click on it, I can add it to favorite or I can add it to engineering data. Favorite list is for some materials which we use very frequently. Okay. Now I will press return to project that as I have applied the material. Here we can see the detail of aluminum alloy in the property window. Young's modulus given in Pascal. In our question we have given it in megapascal. 71,000, 70,000. It's okay. Return to project. Now we will create geometry. Again the window is opening. I will select millimeter as the dimensions are given in millimeter in the problem. Select YZ plane and create a point. I will define point manually. So select manual input. First point is at 0, 0, 0 coordinate. Press generate. Now create second point. Again manual. X coordinate is 500 millimeter. Generate. Now I will create line from these 2 points. I will select these 2 points while pressing Ctrl key and press generate. Now I will have to define cross section, which is tubular cross section. Concept cross section, circular tube. Outside diameter is 12.5 and inside diameter is 10.5. Generate. So now we have created a line and created a cross section, but we have to apply this cross section to this line body. Not selected. Select cross section, circular tube. Here we can rename it we need not worry here. So we have created a model. Okay. Now I will close this section. Here we see our geometry is complete. This check mark indicates that geometry has no problem. Now I will double click model. Our model is open. Here we see a small question mark that our geometry is not complete. Let us see line body, assignment, aluminum alloy. This yellow box indicates that our geometry is not complete. Apply the aluminum alloy. Our geometry is complete. Now we will mesh the model. Here I am not going to resize it, just using automatic meshing. I am not going to resize it, just automatically I will mesh the model. Generate mesh. Mesh is generated. If I want to see cross section, then view cross section solid. Here we can see mesh. We can switch on and off mesh by show mesh or don't show mesh. Okay, now static structure. Okay, now I will apply boundary condition, support, fix support, select point selection method, vertex method, select this node, apply. This is our fixed support. Now we will apply load, force on this node, defined by not by vector. I will define it by component. It is minus 100 Newton in y direction. This is y axis, so this is minus 100 in y direction. Geometry apply. This is our load. Now we have reached to the solution stage. Press solution, beam result. I want bending moment. I want bending moment. Apply. I want shear force. Apply. I want shear force and bending moment diagram. Here I have to define a path and then give path here. Okay, I will again go to model, construction geometry. I will define the path, not by 2 point, I will define it by edge, as we have a straight line here. Apply. We have defined the path, and in shear force and bending moment diagram I will define this path here. Everything is done. Now I want to add stresses. Beam result, or I will right click here, insert beam tool. I will add beam tool here. I will also insert a prop which will show force reaction, fixed support. Insert again a prop which will show moment reaction at fixed support, again fixed support. Now I will solve the problem. Solve. So we have made our model and solve it by Ansys. Now we will see the results. Total bending moment. I can use graphics also. Increase the length. Right click. I can control views. View. Shear force. Right click. Views. Front view. Zoom it a little bit. Now let us check our deflection. Oh, I have not added deflection. So again I will go to solution. Right click. Insert deformation, total deformation. Solve it. Maximum deformation is 6.1334. Let us check. Our analytical solution was 6.18 millimeter. Okay, fair enough. Bending moment 5000. Reaction, force reaction. Reaction is in opposite direction of the applied force. Okay. Moment reaction. It is an arrow coming out of the view, front view. Now we will see shear force and bending moment diagram. This is our bending moment diagram and this is our shear force diagram. Again by arrow, increase the length of arrow, even can change type of arrows. So this is all for today. Thank you.